Tiwari. Dr. Rakesh
Good
Saxena is
morning,
our
everyone.
Hello, good morning, sir.
and Dr. Rakesh Saxena is local
Good morning,
coordinator
sir.
from mechanical department, and Dr. Manish Tiwari is our local coordinator from the industrial and production engineering department. So, Dr. Saxena and Dr. Manish Tiwari, you may like to convey anything to the IIT Roorkee team?
Of course. Uh, Let me first thank the IIT Roorkee team for organizing this webinar. And I have already told my students how important this kind of virtual lab will be, especially in this kind of situation, so that because they are getting the theoretical knowledge through lectures, but this will complement very well the virtual lab knowledge will complement with their theoretical knowledge, and this is going to be very useful and very helpful in this respect. And again, I welcome all my students. And again, I thank Dr. Sudha Arora for organizing this meet and our Dean, College of Technology. And of course, the most important is the IIT Roorkee team.
Hello, sir. This is Manish Tiwari from Industrial and Production Engineering. I welcome on behalf of college and department this IIT Roorkee team. I also welcome my students, Industrial and Production Engineering as well as Mechanical Engineering. Sir, this is really unique experience. This will be unique experience for our students also, as they are going to interact with IIT team. I also thank Dean Madam as well as Sudha Arora Madam for organization of this beautiful virtual lab training session. Thank you.
Thanks to all. I, Amit, and on the behalf of Team Virtual Lab, I welcome all in this webinar. So just give me a few seconds. I'm going to share my screen with you.
Good morning, good morning.
So good morning to all of you. First of all, I would like to say something that in this session, our time is divided into three parts. First, I will describe and give you a brief introduction about virtual lab. Then we will demonstrate you some experiments so a user can able to access and perform these experiments on virtual labs, the demonstration of our virtual labs in second session. And at the end of this session, we will discuss the development activities, means how a user can access and develop their own virtual lab and contribute in this project and become a part of our team. So welcome to all. So the objective of this workshop is to give you a brief introduction, and at the end of this webinar, each and every user is able to understand the working and the development of virtual lab. So please be with us for 1.5 hours. So we will try to explain each and everything related to virtual lab. In this webinar, the agenda, what we discuss, first what is the objective of virtual lab, then we will discuss the features of virtual lab, then we discuss when we have our physical labs, then why we use these virtual labs, then we demonstrate you some experiment, and at the end, the development activities. So what is virtual lab? Virtual lab is a project initiated by the Ministry of Education, Government of India, under the mission entitled National Mission on Education through Information and Communication Technology. When we referring the term information and communication technology, we refer the internet. So government of wants to enhance the learning process of our students with the help of internet only. As you all know that today's days we all are connected and use in internet very frequently. So our Ministry of India wants to use this technology to create an environment in which each and every student can enhance their learning process and try to provide a supplementary material to each and every user with the help of internet. So in virtual lab, we developed a complete learning management system where the students can avail the various tools of learning, including additional web resource, video lectures, animated demonstration, and self-evaluation. So we will try that each and every student becomes self-dependent in terms of knowledge and in terms of skill. So the motivation behind virtual lab is, as you all know, that India is a very vastly diverse in terms of geography and in terms of financial condition. So as you all know that there are so many colleges who are not able to set up the physical labs, the practical labs, due to the constant of cost. As you all know that there are so many experiments which involve sophisticated and very costly equipment. So a college which are not able to set up this type of virtual lab does not provide the good facility to their students to performing the experiment. And if a college somehow set up these type of costly labs, then the updation of their instruments is also become a very costly deal, because as you all know technology changes day by day. So instrument become very curious about the new technology, so that a sophisticated instrument updation is required to each and every college. But it is not possible for every college to update their lab. And as you all know that in the situation like COVID-19, when we are not able to go to our physical lab and not able to perform the experiment on a real instrument, then it will also harm our knowledge base, and a student or a user are not able to get the desired material to fulfill their knowledge for their particular subject or their particular experiment. So to overcome all these problems, we will try to provide an environment in which the physical presence of our user is not required. So the objective of a virtual lab is to provide our user a remote access to lab in various disciplines of science and engineering. And also that, as you all know, that physical lab comes with a constant of time. It means a student or a user are only able to perform an experiment with a limited number of time and limited number of repetition. But in virtual lab, a student is free to learn from their own pace and from their own place. It means a student can perform the experiment 1,000 times without having the foundation of time or situation or place. So a student can perform an experiment 1,000 times until he will not get the basic idea or not fulfill their exact goal of knowledge what he want to learn from a particular object or a particular theory material. So our lab is available 24/7, so a student can perform these labs 1,000 times. And as you all know that in virtual lab we are going to perform the experiment on a simulation. So the availability of limited number of users due to constraint of time and geographical distance be removed in our virtual lab. So when we get all the objective of our virtual lab, then we will find that each and every student must be on the same page. It means each and every student can access the same data and perform the same experiment worldwide on the virtual lab platform. It means that a user is free from the foundation of their branch, from the foundation of their class to perform a particular experiment. So our virtual lab provide a very interdisciplinary environment to our user. So as I told you that in virtual lab we will try to provide a learning management system in which we will try to provide each and every data related to our curriculum, related to our virtual lab on a single platform. So keep that in mind. We provide our user the theory material in the form of e-books, video demonstration, interactive simulation, animation, self-evaluation, quiz, open source content, and various other tools of learning. So a student become independent and perform the experiment and get all the data required to fulfill their knowledge and fulfill their goal on a single platform. So as I told you that our project is come under the mission, National Mission on Education through Information and Communication Technology. So the main portal of this mission is Sakshat. So a student or a user can get updated that what is come from the government side to enhance their learning process with the help of internet. Whenever project is started under this mission is first uploaded on the Sakshat portal, and here you will find there are so many other projects running under this mission, and all these projects are free of cost and available 24/7 to each and every user. So I hope and I wish that each and every student write down the portal name Sakshat and get updated. On Sakshat portal you will find there are so many links, but here you will see that Sakshat portal contains the NPTEL in which a student can access all the video and the theory content related to their curriculum, which is uploaded by the experts and developed by the experts from the IIT and NITs. And there are some other links like spoken tutorial on which a student can access the training of free software, open source software, free of cost and certified from the government end. And at the end we have also virtual lab link. At virtual lab a student can perform the experimentation part. So Sakshat is a complete portal to a student to access and fulfill their knowledge. So here are the features of our lab. As I told you that our labs are available to our students 24/7, and our user can access these labs from their own place. They are not bound to come physically to the lab and perform the experiment. Our user can access and perform the experiment anytime and from anywhere. Then we will have a very common web interface. It means that each and every data related to our experiment is created on a single page of our virtual lab platform. The user are not required to download or go to other website to get the desired data for a particular experiment, he will get all the data on a single page on a single click. Then we will have the facility that if a user have the internet connection and have a PC, then they are able to access and perform all the experiment from all the branches. We developed our virtual lab in a very easy way for our user. Our front end and back end are very user friendly, and a student from class 5th can able to perform the experiment from any engineering branch. And the data you will get from our website are high quality content, because these data are prepared and uploaded by our expertise from IITs and NITs, and quality checks 1,000 times before uploading to our main portal. So a user can easily rely on our data. So here are some difference between physical lab and virtual lab. When we have our physical lab, then why we use our virtual lab? The first thing is the cost. As I told you that to setting up a physical lab requires so many sophisticated instruments, and these instruments come with a cost, a very high cost constant. But in virtual lab, you require a single PC with an internet connection, and you are able to perform all the experiment from all the branches. So the cost become almost zero to setting up a virtual lab in their college. Then we will have the availability. Our physical labs comes with a time bound period, but our virtual labs are available to our student 24/7, and student can perform whenever they want to perform the experiment. Then the experimentation in virtual lab, we will provide a very innovative experience to our user with the help of simulation, animation, and some other types of data. So a process of performing the experiment become very interactive to our user. But in our physical labs, we perform the experiment in a very orthodox manner, and sometimes these orthodox and repetition of experiment become boring to our user. But in virtual lab, it becomes fun for our user to perform the experiment. Then we will discuss the user experience. As I told you that the user experience is best when we work on a real machine. But in the time like COVID-19 lockdown, when we are not able to access these labs, then we will provide the second best experience to our user in the form of virtual. So here are the types of our virtual labs. Typically, we will provide 3 types of virtual labs to our user. First types of labs is modeling and simulation based, in which we will provide a simulator which will work exactly as your real hardware works, and user can access these simulation and perform the experiment and get the reading. The second type of virtual lab is measurement based labs, in which we will provide a calculator type instrument to our user, a simulator to our user, in which user can input their data and get the required and desired output. And at the end, we will try to provide remote triggered labs to our user, in which we will try to provide a direct access to the real hardware with the help of internet to our user, so that a user can access these real hardware and perform the experiment on a real-time basis and get the real-time data. So here are the broad areas in which till now we developed our virtual labs, and we will try to cover up all the curriculum and all the other areas which are not listed in the list till now. So till now we have virtual labs in physical sciences, chemical sciences, mathematical sciences, computer science, electrical, electronics, industrial, mining, chemical, and energy studies, and social science. So here you can see that we will try to develop each and every experiment on virtual lab platform, but till now we have these virtual labs on our platform. So here are the list of participating institute. Here you can see that there are so many IITs and some NITs and some private institute are the team member of our virtual lab project, and we try to develop and cover up all the curriculums across the India, and we are working day and night. So one day we achieve our goal that each and every user can access their desired app on our platform. Here you can see the screenshot of our simulation based virtual labs, which comes under civil engineering. Here you can see that this type of environment we will provide to our user, and here you can see the plane table with the instrument like LED and tripod. So in this environment, our user can perform the experiment and perform the experiment virtually without going to real world. Here you can see the simulation of a electrical machine. You can see the voltmeter, ammeter and wattmeter here, and other motors and other parts which involve in this particular experiment. So here a user can make the connections and perform the experiment, get the reading and plot the graph according to their reading. So this type of virtual lab is simulation type of labs. The national impact of our virtual lab is that till now we have around 1100 nodal centers across India, just like yours, and till date we run approximate 1600 workshops and webinars, in which around 2.5 lakh students and around 3.4 lakh users access these labs and attend these types of webinar and workshops across India, and we will try to touch each and every student in upcoming days. So our outreach team is continuously working that we cover up all the areas in which we are not able to till now develop our virtual lab and cover up all the curriculum and touch each and every student in upcoming days. So here you can see that we will monitor our progress and our work on a daily basis. So here you can see that in overall user experience, our IIT Roorkee virtual labs comes on 4th place. But when we will discuss the experimentation wise, so here you can see that in top 15 experiments, our 12 experiments come in the place which is developed and maintained by our IIT Roorkee team. So here you can see that on first truth table gates developed by our IIT Roorkee team have the greatest number user around 40,000. So here you can see that we will try to rectify and try to improve ourselves on a daily basis. So we maintain a daily analysis of our virtual labs so that we will try, we provide our student a best experience and rectify all our faults. So now how you can access these virtual labs? So a user is only required to the user is only required a PC with a internet connection, so that he just type the URL www.vlab.co.in in their browser. So he will get the first page of our website, on which he will find all the necessary information regarding virtual labs and the list of experiment which he want to perform are listed on this page. Then we will also have a second portal or a second website on which we uploaded the experiment which is developed by our nodal coordinators with the help of our nodal coordinators, nodal centers students. So they also become a part of our team and contribute their knowledge in our project and develop their own virtual lab and become a part of our team. So here you can see the portal VLab Dev on which each and every experiment developed by our nodal centers is uploaded. So our user are those students who are not able to somehow access this type of sophisticated instrument, and the students who are in schools and possibly motivated themselves to keep up that what subject he want to pursue in their future studies or higher studies, because as I told you that our experiments are very user friendly and very easy to perform. So a student from school level also perform these types of experiment, and on virtual lab we will try to provide a environment on which we can share our resources. Like if you have some good knowledge for a particular subject, then you can share your knowledge on virtual lab platform, become a part of our team. So this is the end of our introduction session, and if you have any query related to the virtual lab till now, please feel free, or we will move to our next session on which Mr. Chetan will describe you and explain you that how a user can access these virtual labs and perform the experiment on virtual lab platform. So if you have any query, then please feel free, or otherwise we will switch to our next session.
Uh, Dr. Saxena, Dr. Tiwari, if you have any query or your students, they are welcome to ask. Saxena sir, am I audible?
Yes, yes, yes. No, this was very useful and informative, all the information so far. And again, I will ask my students anytime if you have any queries or doubts, please feel free to ask Dr. Dhiman or any of the IIT Roorkee team. Okay? They'll be glad to answer your queries.
Okay, thank you, sir. So we switch to our next session in which we will demonstrate you some of experiment. So I invite Mr. Chetan. Chetan sir, please.
Thank you, Amit sir, for such a wonderful information about the virtual lab. Hello and welcome. I'm Chetan from Virtual Lab Electrical Engineering Department, and now I'm here with you for some time to demonstrate you some of the experiments on the mechanical engineering. And just give me a second, I'll share my screen. Uh, So as Metsar told you that we have a common web interface that is named Virtual Lab, and we have a URL www.vlab.co.in. So if you want to just access these labs, just go to www.vlab.co.in. Just open your browser, any of your browser like Google Chrome, Mozilla Firefox, Opera, Internet Explorer, anything else. Yeah, Microsoft Edge also. So just write there vlab.co.in, and this kind of page will appear on your screen. So this is our basic first page of our website, and this page is basically divided into three different parts. So we categorize this page into three parts. The first one is the general information about the project, its objective, philosophy, and the silent features. So if you want to just study these things, just go to these parts. And then we have a list of our broad areas. So basically, in the under the broad areas, we categorize the experiments and the labs with the help of their streams. And if you want to perform any of the experiment from any of the branch, just go to the particular branch and perform the experiment. So if you are from the just like you are from the mechanical engineering and industry, you just go to the mechanical engineering tab and perform the experiment, and by following the necessity requirement of the experiment. And we have the second tab of participating institutes. So basically, these are the backbone of our virtual lab project. And from 2009, we are continuously developing the experiments and explore the experiments and evaluate these experiments from that particular time period. So if you want to just check what are the contribution by different institutes, so just go to any of the institute and the check whether the what are the developments and what are the fields of each and every institute developed in this particular experiment. So from 2009 to 2012, we developed some approximately 50 experiments initially, and after that we will just elaborate these experiments to the students and to the faculty members of different institutes for their reviews. And also at that time we use some of the paid softwares like Adobe Flash Players, LabVIEWs, MATLabs, and Quest 3D players to generate the experiments, because we have that facilities at that time. But as the time goes, but as but as the time goes, some of the facilities are not available now. So what we are doing is that we are just converting the experiments which are developed on the paid softwares to the open source environment. So after 2015, the newly developed experiment, which is right now more than 250 different labs, is available on both the portals. So we are just developing these labs on a open source environment, so like Java, HTML, Python, like Java, HTML, Python. We are using these kind of the things. So, and right now we are just converting the existing labs to the open source environment also. So some of the in the pipeline and some are done. So at the last we have the VLab development portal. So basically on this particular VLab development portal, we introduce some of the new experiments which are recently developed on the open source environment. And after the quality analysis of that particular experiments, we move that experiment from this particular secondary portal to the main portal of vlab.co.in. So we'll show you the lab from both the portals today, from the central portal, that is vlab.co.in, and secondly the virtual lab development portal. So let's start with the experimentation. So I'll repeat once again. To access the experiment, just go to vlab.co.in, or you write on the Google that virtual labs. So this page will come up. And let's start with the first year basic experiment of the students for mechanical engineering from machine tools lab. So that experiment is available as it is newly developed experiment, and it is available in the VLab Dev portal. So just click on the VLab Dev portal. On the secondary on it takes me to the secondary portal, and we have this explore labs option here. So we have three tabs here. In the first one, we have some videos of the experiments, how to perform the experiment on that particular experiment. And then we have some approved labs which are already approved and ready to move to our central portal and in the process. And some are in the labs under development, means they are still going in the development part. So I'll just click on the approved labs, and in this we have some of the labs which are already developed and quality analyzed, and we have this machine tools lab available in our mechanical engineering department. So I'll click on this machine engineering. So basically this lab is completed by MIT Aurangabad. So this is one of the nodal center of MIT Bombay, and they are just developed this experiment. The students of this particular institute develop this experiment and provide for the national use. So as I click on the explore, it will take me to the experiment, and we have a example of life estimation of a single point cutting tool during turning process. So as I click on this, so basically this is our lab manual. As you go to your physical laboratories, you have lab manuals of each and every experiment. In that lab manual, you have objective, theory, procedure, results, graphs, everything is there. So similarly here we have the aim, objective, then we have the theory. So basically this is the complete theory of this particular experiment and related to the experiments. And then we have a pre-test. So basically what is the functionality of the pre-test here is if you are just going to perform this experiment or any of the experiment, and you are a new user for this virtual lab, so before going to the actual experiment, we have some questions for you so that you can check whether you have some basic knowledge about this experiment, or you have to revise the theory part or not. So just perform this pre-test and check your knowledge once. So I'll click at randomly for the questions, and then we have the evaluate button. So I have the first answer is correct while the other are wrong. So now that to our procedure. So this is the procedure, and it is very important for the first time user to perform the actual environment. And one another thing comes here is that when we are performing the experiment in our physical laboratory, we have we have to perform the experiment very precisely, because in each of the mechanical experiments there is a very large amount of risk for performing the experiment for our health also and for the equipment also. So before going to the particular experiment, you just follow the procedure and perform the experiment, and then we have the simulation. So basically, this lab we were designed because in the machine tools lab we have actual machines available with us, but right here we are not able to perform any of the experiment with the help of actual machine. So what we are doing, we provide some of the questions on the basis of our machine tools, and by answering these type of the questions you are able to perform the particular experiment. And this is the first question here. So identify the lathe machine from the following. So basically these are the four machines I have, and I have to identify the lathe machine from this one, any of this one. So if I press any of the wrong answer, it will show me that your answer is wrong. Please check another. So like I'll click on this particular drill machine, and it shows me that sorry, you have not selected a proper machine. Okay. So we have this. Know that this is our lathe machine. So I'll click on this. Then we will move to our second part. Then the second answer question is identify the parts of lathe machine. So basically we have this lathe machine and we have different parts available with us. So these parts are come up at random. Not all the parts are come in the single time, but they are in the at random format. So I have to click on the actual part and then to the machine, the placement of that part, and it shows me that the answer is correct or wrong. Like the headstock. I think this is the headstock of our machine. Then the tailstock. So this is the tailstock. Sorry, tailstock of this of the machine or plate machine. Then we have the bed. So I'll click here and it should say me that try again, select bed. So because this is not the bed. So this is the bed. Then the carriage. This is the carriage. Lead screw. The rod connecting the headstock and the tailstock is a lead screw. And tool post. So basically this is our tool post, and spindle. Basically this is the spindle, and the legs, these are the legs. So after selecting each and every component correctly, we have to move to our next option. So that is next. Then we have another question: which of the following is not a part of our carriage in center lathe? So the tool post, apron, component rest, compound rest, or the gearbox control. So I think the gearbox control is not the part of our center lathe. Click on the next. Then we have another question. So select the tool and locate it on lathe machine. So we have three tools available with us: the high carbon steel, the HSS 1841, the carbide. So I'll choose the high carbon steel. Okay. So as I choose the high carbon steel, and I have to place my high carbon steel tool to my tool post. Then click on the next. Then we have another question: which one is the hardest tool material? So I think HSS, carbide, cemented carbide, or CBN. So I think the CBN is the correct one. Click on CBN and next. Then select the workpiece material and locate it on lathe machine. So you can choose any of the material available here. So yellow, brass, bronze, or aluminum. So I'll choose aluminum and place it to the carriage, and then click on the next. So we have another question here. So which of the following represent the unit of cutting speed? So meter minute, minute per minute, meter per minute, or none of the mention. So I think the meter per minute is the correct answer. So which of the following represent the formula for cutting speed? So CS is equals to 3.14 dn is a formula for our cutting speed. where d is the diameter of work and n is the round per meter. Meaning. Then I have to select the speed. So you can choose the speed between 21 to 30. So I'll choose it as 30 and click on next. Now we have another question. So what is the necessary condition for turning? So material of workpiece should be harder than the cutting tool. So what is means that the tool is of our tool is not harder as per our material. If it's true, then the material will never be worked. So this is wrong. Then cutting tool should be harder than the material of work. So this is correct one, because if the cutting tool is of harder than the material, it will properly work. And if they are of the same hardness, then there may be not the proper work done. So the second one is the correct option. And click on the next. Now we have to find out the Taylor's tool equation. So what is the Taylor's equations? V into T raised to the power n is equals to C. Click on the next. Now at the last, we have we have our observations like cutting speed, the tool life exponent, and machine constant, and we have to find the Taylor's tool's life. So just calculate with the help of the formula and put it here and check your answer. So basically, this is the first experiment, and in this first experiment, we revise our first year of workshop, that how we are able to use the experiment of workshop and what are the different steps to perform the particular experiment and what are the different parts of a particular machine. So basically, this is a very basic experiment available with us. So this is from the first experiment, and I'll show you once again that virtual lab vlab.co.in is a place where you can get each and every experiments available, and you are able to perform the experiment by following the procedure. Now we will move to our second experiment, that is from the mechanics of machine labs. So I'll click on machine mechanical engineering again. Then we have a mechanics of machine labs. Uh, So the mechanics of machine lab is developed by NIT Karnataka. So it is stated here, and you can also check the different experiments available. Again, the similar pattern is available here, that we have the introductions, then we have the experiments, the target audience, course aligned. So I have to click on the experiment, and this is the complete experiments available here for the working. So you can check any of the experiment from here, and by following the procedure, you are able to perform the experiment. So I'll click on the universal joint. So this is the last one experiment. Similarly, we have our lab manual, as I told you earlier. We have lab manual here again, and we have the theory, the objective. This is the complete theory. So once you check the theory completely, then go to the procedure. So just by following the procedure, you are able to perform the experiment virtually as well as in your actual laboratory. So these are the questions for your self-evaluation. You can check these also. Then we have the simulation. So initially, when we are going to perform this experiment, in the beginning, the two shafts are rotating. So these are the two shafts. One is the input shaft and second is the output shaft. So the output shaft was inclined at the 40-degree angle initially in this particular experiment, and input shaft has the angular velocity of 0.4 radians per second. So in this particular experiments, we have the controls and the values according to the input and the output is available in the bottom of this particular experiment. So you can pause this particular experiment and you are able to fill the values of beta and theta and omega. So let's fill the value of omega as 180 and just play that, and you can hear you are able to change the value of beta from here and change the value of omega from here. And as you click on the graph button, show graph, the graphs of these particular the graph between the output shaft and the angle and input shaft is available, and the output shaft and the input shaft and angle degree with the help of the velocity is also available. So you can change the values and you are able to check the different changing in the graph. So basically, this is the first experiment of universal joint. You are able to change the value of beta as well as omega as well as theta with the help of the variables available, and by varying the values, you are able to check the graph of each and every positions and the output and the input of this particular universal joints. So basically, initially we fitted down that with the 40 and 0.4 combination, but right now we change these values from 60 to 1, and these are the output of the angle and the output of the output shaft angle and input shaft angle. So this is the graph of output shaft angle and input shaft angle, and this is the graph of output shaft velocity versus input shaft angle. So you can also change once again and check the result again. So this is the this is the second experiment of universal joints in the mechanics of machine laboratory. So we have another experiment in this particular lab also. You can check all that also. The crank and slotted mechanism. So this is the second last experiment, the crank and slotted mechanism of this virtual lab. The similar environment is available here, the theory, the procedure. So firstly, you have to check the theory. This is the complete theory for our mathematical, for our crank and slotted mechanism, and then we have the procedure. So basically this is the procedure, and you are able to check the vectors as well as the angular velocity readings of this particular crank and slotted mechanism. So, and as I click on the simulation, we have this particular arrangement available. This is the mathematical arrangement of our crank and slotted crank and slots. So we have the values OA. This one, this red arm is the OA, the BC. So basically, this green one is the BC, and the CD. So basically, this black one is the CND, and we have again the input angle in theta, and we have the values of vectors in mm per seconds and in the ratio of 0 is to 0.8, and also to the 1 is to and also the acceleration diagram also available with the scale of 1 is to 0.5, and also in the scale of 1 is to 1 in the reverse direction, clockwise or anti-clockwise direction both. So you are able to make the changes in this particular experiment and note down the values and calculate on your papers and check whether the results are similar or we have some of the errors available here. So I'll change the value of OA, BC and CD and also the input angle at random and click on start. So it shows me that the vectors VA, VE, VC, VB and VCD and the values are continuously changed. And also the acceleration diagram again we have, and the different components of the acceleration diagram in the form of vectors is also available, and this is the for and clockwise direction. This result is for the clockwise direction, and we have the different angular velocity accelerations diagram and also the velocity diagram available here. So basically this is another basic experiment available in this particular mechanical engineering. So now let's move to a third experiment. So in the third experiment, I'm going to demonstrate the experiment from Dynamics and Vibration Laboratory. Machine Dynamics and Vibration Laboratories. And this is the experiment, and we have some of the experiments available. So like the first experiment is for free vibration of cantilever beam. So I'll click here, the free vibration of cantilever beam. So for the first time user, just revise your theory and procedure, check the procedure. So in this particular experiment, we use the stationary aircraft wing as a cantilever beam and perform the experiment. So for example, we use these, and these are the calculations. So just check the theory once, and then we have the procedure. So this is basically the procedure of our experiment. Just check this particular procedure and follow the experiment to perform this particular experiment. Then we have for the self-evaluation some of the questions available. Then we have the simulators. So basically in the simulators we have several topics available, several tabs available. In this we have the tutorial. So for the students, you want to check the tutorial in the video format, just click on the EXPN, and then we have the experiment with EXPR. So basically this is the experiment, and in this particular experiment the cantilever beam is available here, and this is the beam section, and this one is the springman damping system. So when you go take the mouse to any of the component, it shows the statistics of that particular component and the statistics of this beam dimensional. And here in the controls, you are able to change the value of this the material, the steel, aluminum, and the bronze. Then you are able to change the cross-sectional area of the load also, like T section, C section, L, I, square section, and in the other section you are able to you are able to provide provide your customized values to this particular load. And in the end we have the and mask. So for in this particular experiment, as I choose the bronze as, or let's the steel as the material, then we choose the cross sectional area as I. We can choose this as a T, then C, and the components characteristics is also available when we place our mouse to this particular load material. And suppose we choose this as I, and we have the length in also. You can able to change the value of this particular length, let's say this 2000, and then you can also able to change the damping ratio and the end mass of our cantilever beam. And these are the outputs and the readings available in case of the mass, the K, C, omega and omega D. And as you click on the button, it inputs the values of your system and give you the output. So as you click on the graph, it shows you that the different in case of the graph window, the displacement versus time graph is available in the fast Fourier transform form, and you can also change the damping ratio and check the change in the graphs available. So this is the experiment here. Also in the result section, the values are also changed, and you can note it down also these things. You can also change the cross-sectional area as T, and now the damping area ratios. You can vary these damping ratio and check. You can vary the mass, and you can check the displacement in time graph also. You can change the section, and some changes also done in these particular combinations. You can change the value of your length also. As you click on the play, it's basically the windows available for this particular single freedom system. So basically, this is the third experiment of our virtual lab which we are going to show you, and you can also check any of the experiment available in this particular field. And the best and the easy practice that just go to the procedure, follow the procedure, and perform the experiment. And for performing the experiment, it is not necessary that you are from mechanical engineering or the industrial engineering. You have to perform the experiment from these branches only. So you have the freedom here that you are able to perform the experiment from any of the branch. Like if you want to perform the experiment from civil engineering, just go to the civil engineering branch and perform the experiment. And if you want to perform experiment from electronics engineering, just go to that electronics engineering section and perform the experiment you want. So what is the best utilization of these experiments? So according to me or our feedbacks with the students, that you are going to perform the particular experiment in actual field. So at that time, you first time users, you are not know about the how to use the experiment, how to use the kits, how to use the equipments, and before coming to the mentor of your college or your lab in charge, you are basically going to waste your time, because in your college, I think there is a group of each 5 to 6 persons, and it takes some time to reach to every group. So once you perform the experiment on virtual labs, and after that performing the experiment on virtual lab and going to the physical laboratory, at least you have the knowledge about the basic knowledge about the experiment, and you are able to make the connections in the particular experiment. You are able to issue the certificate, issue the uh, components in this particular experiment or any of the experiments. So you have the basic knowledge. And also in this COVID-19 situation, you are not able to perform experiment physically in the practical labs. So at this particular time period, this is the best second option available, as we also shows you in the introduction part, that what is the best option available. We don't say that you can replace the actual laboratories with the virtual lab, but this is the second best option available nowadays, and it is also completely free of cost and easy to use by just giving the inputs with the help of your keyboards and the mouse. So guys, this is from the basic some of the basic experiments available in the mechanical engineering in our virtual lab platform. So now if you guys have any query, you can ask, or we will move to our new some of the another experiment. And also in this particular virtual lab, we have a very well set up and good lab of fluid mechanics. You can also check that lab in the fluid mechanics section. Just go to here and search fluid mechanics lab. So in that lab, you have different 4 to 5 experiments, but they are very good experiments if you are just going to perform those experiments on your own. So you can check those experiments also. So guys, if you have any query, you please ask. And
Thank you, sir. It was, I think, very informative session for the students as well as for the faculty who has joined here with us. 4 5 faculty have already joined. So, Dr. Saxena and Dr. Tiwari, I think you may be having some query because you already have a very good CAD lab in our college.
Yes.
So, yeah, sure.
Let me make a quick comment on what we are doing here. In our CAD lab, we have taken a FreeMat software, which is an again open source software, and which is very similar to MATLAB. And so all our students, they have also downloaded this FreeMat software, and we have started programming FreeMat with all the graphic entities, splines, Bezier curves, yet to come, but we have started with analytic curves. So, and we'll also include Creo and ANSYS, which we already have licenses. So we'll have hopefully we'll have a good CAD lab or virtual CAD lab by the end of this semester. Now, I have a question. First, I would like to thank Dr. Dhiman about his time and effort to provide this excellent facility of virtual lab to our students, and of course, the rest of the IIT Roorkee team, and of course, our Dean, College of Technology, for her constant encouragement, enthusiasm, and of course, Dr. Sudha Arora for very useful endeavor. Now, I have some quick question for IIT Roorkee team. Our students, how do our students can get involved in this, besides, of course, doing the experiment? How can they develop these experiments, or how can they be issued some sort of certificates so that they can add it to their resume, etc.?
Okay, thank you so much, sir, for this particular query. But as we initially told you that we have the third session of our development session, and this query is for basically the complete session for the development. So we just going to explain each and every module and each and everything in that session, so that the students will get the clear knowledge about how they are able to perform their new experiments, how they are able to develop their new experiment and provide that experiments to this particular portal. Okay. So we will just going to demonstrate some of the things in that particular development session. So just wait for 5 to 10 minutes. We will start that session. And
Great.
your query will be clear at that time. And also we met some of the institute students, like you have a very well set up CAD lab available. But in some of the institutes, we tackle that the problem that they don't have a well settled lab of mechanical engineering as well as for the civil engineering, because these labs are very costly. But each and every institute is not able to purchase these labs and set up these labs. So at that time, we just think that how quality labs are available for the students, as because they are not going to perform any of the experiment throughout the year or throughout the semester, and at least they have the knowledge that this kind of the experiment is available in some of the institutes physically, and they are used to perform these experiments on that platforms. So this is very good thing that we have such a prestigious institutes in our Uttarakhand, that they have each and every modules and each and every facilities available. But as we compared the institutes, some of the private institutes available, and they don't have the facilities. Even basic labs are also not well set up. So at that time, we just get the uh, I think get the actual value of virtual lab for the students. And also, when the students going to use these virtual labs, and they think that they just find the data is available in this particular virtual labs and it's available, so I think they will just find these also. And also in these labs, we use in some of the labs we use the actual error technologies. Like in our formula based experiments, we have the actual results available. But while we are performing the experiment in the physical laboratory, we have the error of approximately 4 to 5%. At that percent will be introduced in this particular experiment, and we provide both results, like the experimental result and the actual results available. So we are just going to add on in some of the experiments also these kind of the things. So thank you so much for your query and your appreciations. Thank you, sir.
Thank you.
Dr. Saxena, if any other faculty has any query, you can ask them to clarify it.
Right now, I'm in my office, and
Okay.
if anybody is here, they are always welcome to ask questions. Also, the students, I strongly encourage all the students, whatever small query you have at this point, please go ahead and ask. Okay.
Or you can also write your queries in the chat box also. We can read out from there also. If you just don't want to on your mic and speak up. So you can also write your queries in the chat box. Okay, and another important information for the students is that right now you don't have any, I think, don't have any query, and we have our YouTube channel like Virtual Lab IITR, and at that channel we have some of the interesting videos available and how to perform the experiments of each and every fields. The videos are available, and this particular session is also going live in the YouTube. So just if you want to check these particular sessions and check another information sessions in future, just go to our YouTube channel like Virtual Lab IITR. We will share the link in the chat box, and please like, share, and subscribe our YouTube channel for more updates. And also, if you have any suggestions of what kind of the videos must be available in our channel, so it is very appreciable to you also. So thank you guys for this session, and now I'll hand over the mic to Mr. Jasmeet Singh, and he is going to give you the demonstration about the how to perform the experiment, how to develop the new experiment, and what is the procedure to develop some of the new experiments. So over to you, sir. Thank you for so much, guys, for this particular session, and we will. If you guys have any query, just write in the chat box. Thank you so much. So over to you, sir.
Yes, sir. I would also like to thank Dhiman sir for today's beautiful session on this experimental part, particularly the live testing of single point cutting tool. It was explained in a simple and elaborative way. So I would also like to request my particularly IPE students to ask any questions. Definitely, we have got some insight into how this experimentation is done, and it will help us to get involved in this how this experiments can be developed this platform. Yes, IP students, I request to ask questions if any doubts.
So, Manishji, I think we must now continue with the other session.
Okay,
Students,
okay, madam.
if have any query, they can contact you, and if they can contact directly also.
Okay, okay.
Yeah.
Thank
So Chetanji, you may carry on.
Hello.
Yeah.
Hello. Good morning, ma'am. Good morning to all of you. My name is Jasbir Singh.
Yeah, just
Now,
good
hello.
morning.
Yes,
Good
ma'am.
morning. Yes.
Okay. Okay. So I hope all of you will get the idea about virtual labs, how to use these virtual labs, how to do the experiments in virtual lab website. So I think you will get some queries after when you perform these experiments. So now we will start the process how to develop these experiments, or how you will be a part of development team, or how you will contribute to these virtual labs. Okay. So first of all, the main objective here is inclusion of nodal centers in development activity. So why it is so? As all of you know that our main website, that is vlab.co.in, that is a virtual lab portal that is created by MHRD. Means MHRD have started a program that is named Virtual Labs with the help of a scheme that is named NMEICT, National Mission on Education through Information and Communication Technology. And in our VLab dev portal, or in our vlab.co.in portal, we have around 220 labs right now, and we are 12 participating institutes. But ministry wants that if is there any lab that is used in a particular institute, and that lab is not on virtual lab portal, we should include those lab on virtual lab portal on VLab website. So that's why they include these nodal centers. Like if you have any lab that is used in your college, in your prestigious institute, and that lab is not on particular vlab.co.in, then we have to include, or we have to develop those lab, and we have to include those labs on vlab.co.in, so that every student get an alternate lab apart from their real-time lab. They will get a alternate way or alternate lab on a online platform. Okay, so that's why we include nodal centers, because it is not easy for only 12 participating institutes to build so much of data and so much of content, because in India we have so much of laboratory that are used on the institutes. Okay, so that's why we include nodal centers, and we invite nodal centers to help us in this development activity. After that, encourage the participants to be part of virtual labs community. How will encourage means, if you develop some lab and you successfully submit those labs, we'll give you some certification. So that this certificate is very beneficial for your resume also. And apart from that, this is for noble cause also. Like if you develop a lab, it will go to vlab.co.in, and many other students will get help from that particular lab. Okay, like you students now in this pandemic situation, you are doing such experiments on virtual lab portal, so these things will help others also. After that, develop web enabled quality labs. Quality labs means that particular lab you develop, it will contain everything. Okay. The theory part, the procedure part, or video lectures, or references, all the data. We have to develop a quality labs. If a student will come go to experiment, he will get, or he or she will get all the information regarding that particular experiment. ओके, आई थिंक दिस थिंग्स विल क्लियर टू यू। मींस फर्स्ट ऑफ ऑल आप लोगों को हम लोग इनवाइट करते हैं, इंक्लूड करते हैं हम लोग नोडल सेंटर्स को डेवलपमेंट एक्टिविटी में, ताकि वो लोग भी इसमें पार्टिसिपेट करें और अपना कुछ कंट्रीब्यूशन दें। आफ्टर दैट, एनकरेज द पार्टिसिपेंट, मींस हम आपको सर्टिफिकेशन प्रोवाइड करते हैं अगर आप लोग कोई लैब बनाते हैं, उसको सक्सेसफुली आप लोग हमें सबमिट करते हैं। आफ्टर दैट, हम लोगों को ऐसी लैब्स बनानी है जो क्वालिटी लैब्स, मींस उस पर्टिकुलर लैब में हमें वो हर चीज मिले, एक स्टूडेंट को वो हर चीज मिले जो उसको एक रियल टाइम लैब में मिलती है। मींस our main motto is he or she will get all the information or all the knowledge regarding that particular experiment. Okay, after that, the development model. So our development model will be part in 6 parts. First is invitation. That is from our side. We will invite you. Means we will send an invitation to our nodal centers that you will be a part of nodal center in a development activity or development team. And you will be part of VLab community also. Okay. After that, when we send the invitation, what we'll do, we will send a proposal to us, and that proposal will include 3 things. First is gap area labs. Second one is student team details. Third one is software details. Gap area labs means, suppose now exactly we have 220 labs on VLab portal, and suppose there is a lab that is used in your institute, but that particular lab is not on virtual lab portal. That is called a gap area. Means gap area क्या है? वो labs जो अभी हमारे VLab portal पर नहीं है, हम लोगों को उनको आइडेंटिफाई करना है, उन लैब्स को देखना है कि ये लैब हमारे वी लैब पोर्टल पर नहीं है या वी लैब .co.in पोर्टल पर नहीं है। हमें उन लैब्स को बनाना है जो पर्टिकुलरली लैब अभी हमारे वी लैब प्लेटफॉर्म पर नहीं है। तो दैट इज कॉल्ड अ गैप एरिया. After that, student team details. In your particular proposal, you have to send a student team details. Means your team will include how many students and what are the software they will use for their particular experiments or their particular lab. Okay, I think you'll get that. Proposal is gap area. First of all, you have to find out the gap area. Gap area means you have to find out those labs which are not on VLab platform. After that, student team detail. You have to send your team details, and after that, software details means you have to send the software details which you are going to be using that particular labs. After that, how the development will work. We will develop four things. First one, front end and back end coding means we have to design the front end of that particular experiment, and we have to develop the back end also, means how the back end coding will work. After that, the content development. Content means you have to prepare the theory part for that particular lab manual. When you go to a lab, you will find a lab manual there. It includes the procedure, how to proceed to the experiment, or how to work on that particular experiment on the theory part. So that is called content development. So that's why in your sprint team details, we include our team structure is like that. We'll come to this point later. Our team structure is like that. We have 5 team members in a particular team, and 2 of them will be from coding part, that is from computer science or any other branch, and 3 from the particular lab branch. Means if you are going to develop a lab from mechanical engineering, 3 students should be from mechanical engineering, so that they will help in content development, the theory part, the procedure part, or the like that is called we have some quiz section. We have to prepare some content for that also. After that, supporting documents. Supporting documents means like video lectures about that particular experiment. Some of the students will do the experiment, will show a video, so that students will understand how this experiment will work. After that, the references, from where you will take the references from any book or any other journals, any other things. And after these things, you have to import those experiments in a VLab template. That is from our side. Means you have to develop from a lab, you have to make the content, and you have to send to us. We'll send you a portal, we'll send you a template. In that particular template, you have to import those experiments. And for all the experiments, we have a same template. As you seen in vlab.co.in, we have a same template for every experiment. It means if you click on experiment, you will get everything, like theory part is there, procedure part is there, some quiz section is there, the reference documents are there, and then that simulation window. So this template is same for all the experiments. Okay, I hope you will get all these 3 things. First one is invitation. हम लोग आपको invite करेंगे आप लोगों को कि आप लोग एक डेवलपमेंट एक्टिविटी का पार्ट बने. आफ्टर दैट आप लोगों को हमें एक प्रपोजल सेंड करना है अपनी टीम डिटेल्स और सॉफ्टवेयर डिटेल्स के साथ कि आप लोग कौन सी लैब पर्टिकुलर डेवलप करने वाले हैं. आफ्टर दैट उस डेवलपमेंट में हम लोग क्या क्या करेंगे, हम लोगों को फ्रंट एंड और बैक एंड हम लोगों को प्रिपेयर करना है, हम लोगों को उसका कंटेंट प्रिपेयर करना है पर्टिकुलर लैब का, एंड सपोर्टिंग डॉक्यूमेंट्स. इन सब चीज़ों को प्रिपेयर करने के बाद हमें उन सब डॉक्यूमेंट्स को एक लैब टेम्पलेट में एक्सपोर्ट करना, इंपोर्ट करना चाहिए. ओके, you will get these things. After that, the fourth part is submission. Like you have developed the lab, you have upload all the, you have import all the lab, all the experiments on your VLab template. After that, you have to submit those labs. You have to submit those labs on VLabs template. First one is upload simulator code on GitLab. You have to push your codes on GitLab. For this is for the team only. Like if you create a team, all the team members should have a GitLab ID. When you create your code, when you make your code, you have to push those codes on GitLab, and these codes should be on a lab template, that is VLab template. After that, we'll upload all the documents by you on a VLab dev portal. That is for the use of other users. Like आप अगर कोई भी लैब बनाते हैं, आप लोग हमें डॉक्यूमेंट सेंड करेंगे, वो डॉक्यूमेंट्स हम लोग क्या करेंगे, एक VLab डेव पोर्टल है उस पर अपलोड करेंगे, ताकि वो यूजर्स के लिए रेडी रहे, वो लोग उसको यूज करें. अगर उसमें कुछ कमी है वो लोग हमें बताएं, कुछ कमेंट्स करें, ताकि हम लोग उसको रेक्टिफाई कर सकें. After that, review. There is a review committee for all the experiments. That is called a VLabs dev committee. They will review your lab. They will give some comments on your lab. You have to rectify those comments. After that, that particular lab, after these rectification of these particular comments, those labs will be host on central portal, that is vlab.co.in. Okay, and after that we will provide you certificates to the nodal coordinator as well as the team members. Okay, so there are 6 parts. First one is we will send you invitation. After that you have to send us a proposal. After that we'll make those labs, or we'll give you some help about your experiments or your lab. After that, when you complete your lab, when you successfully complete your lab, you have to submit those labs to on GitLab. After that, we'll send those documents on a VLab portal so that students can use those labs. After that, these labs will be reviewed by a review committee, and after that, after the completion of lab, and this lab will go to the vlab.co.in portal, we will provide you certificates. Okay, am I clear to all of you? Okay. So how the development activity will work? So this is 2 type of activity we have already done. One is boot camp in IIT Roorkee. We'll organize a boot camp in IIT Roorkee. We invite all the participants from different institutes to come to IIT Roorkee, and here we organize a boot camp for 5 or 6 or 7 days maximum, so that they will come here and do some experiments or be a part of development activity. Or second one is nodal center in-house bootcamp. Our team will come to your institute, and same the time will be same, 5 or 6 or 7 days. We'll organize a bootcamp in your institute and we'll develop the experiments there. Okay. सो दो टाइप की एक्टिविटी रहेंगी. एक रहेगी हम लोग आईआईटी रुड़की में एक बूट कैंप ऑर्गेनाइज करेंगे, जिसमें हम लोग आप लोगों को इनवाइट करेंगे. डिफरेंट इंस्टीट्यूट से हम टीम्स को सिलेक्ट करते हैं और उनको आईआईटी रुड़की में बुलाते हैं, ताकि वो लोग यहाँ पे आएँ और हम एक 5-6 दिन का कोई बूट कैंप रखते हैं, जिसमें हम आपको कैसे एक एक्सपेरिमेंट को डेवलप करना है वो चीज़ें बताते हैं. या फिर हमारी टीम आपके नोडल सेंटर मीन्स आपके इंस्टीट्यूट में आएगी और वहाँ पे आपको ये सारी चीज़ें एक्सप्लेन करेंगे कि कैसे आपको स्टेप बाय स्टेप एक्सपेरिमेंट्स को डेवलप करना है. ठीक है. Okay, so what are the privileges that we get by institute? First one is the certificate will provide to all the team members as well as the nodal coordinator. After that, students are eligible to attend national level boot camp. This national level boot camp is organized by IIT Hyderabad or IIT Bombay, and all the 12 participating institute can participate in this national level boot camp. So if you are a part of IIT Roorkee, means virtual lab IIT, as you are a nodal center of IIT Roorkee, and you contribute to some labs, you are also eligible to attend those national level boot camps. After that, students are eligible to apply for internships. If there are 2 types of internships in IIT Roorkee, one is the simple way, like you have to you will get a link from DSW, and after that you have to apply for that internship. Second one is with this virtual lab, like Dr. R.S. Anand is our nodal coordinator, our PI, principal investigator. You can do an internship under him. Like you want to perform some experiment, you want to develop some experiment in virtual lab, you can apply for internship here also. After that, institute get the support by team virtual labs for in-house development. Like our team will come to you, come to your institute, and will do the development activity. After that, this is one important thing. There is a newsletter named Abhasi, which is published by MHRD. If your institute is a part of IIT Roorkee and you also contribute to some development activity, we will publish your name as signing nodal center in that particular Abhasi newsletter. So these are the types of certificates. Like first of all, bronze certificate. If a particular team develop a single experiment, like we will invite you in IIT Roorkee, we will invite all the teams, like 5 or 6 or 7 teams in IIT Roorkee, and they develop single experiment. Then we will provide a single team a bronze certificate. If a particular team develop a particular lab, means you develop a complete lab, we will provide you silver certificate. And if that particular team develop another lab, means 2 labs or max 3 labs, we will provide you golden certificate, golden developer of VLab community. Okay, so these are the statistics. Means these labs, like computer science engineering, 24 labs, these labs are already developed and these are on vlab.co.in portal. So these are the gap area labs. Means there are 28 labs are there which we can develop. अभी 28 labs वो हैं जिन पे अभी हम काम कर सकते हैं, and this data is on the based of syllabus of 5 or 6 universities. that is not only 28, maybe there are more, like अभी ज़्यादा भी हो सकती हैं, ऐसा नहीं है कि सिर्फ 28 लैब्स हैं। तो हमें ये गैप एरिया फाइंड आउट करना है, हमें देखना है कि कौन सी ऐसी लैब है जो भी हमारी vlab.co.in पोर्टल पे नहीं है और हम लोगों को वही लैब डेवलप करनी है। ओके, am I clear to all of you? Yes, any response?
Yes, sir.
Okay.
Yes, I
Okay.
think this information will be very useful for the students
Yes, ma'am.
because, as you have discussed, they will not only get the exposure to the development platform, but they will have the benefit of interacting with the IIT Roorkee faculty as well as students.
Yeah, exactly, ma'am. And
So
if they
they
come for internship, they will get some more exposure in IT.
so they will get the benefit from both, and that too without bearing any cost.
Yes, ma'am. This is beneficial for all three, like for institute also, for faculty members also, and for students also.
So this platform will be very useful for them, I think, and the students, once
Uh,
they will be used to of it, they will get, I think, better opportunity during the jobs as well as if they want to go for research purpose, they will be benefited by it.
मैम आपकी आवाज़ थोड़ी क्लियर नहीं है, किसी का माइक होना शायद। सर एक बार म्यूट करूँ, आई थिंक किसी का माइक
I,
ऑन रह गया है।
yes,
Okay, so we'll move further. This is how to find the gap areas of virtual labs. Means how you can find out. Just go to central website, that is vlab.co.in. Go to your particular branch on which you have to develop that lab. Like if you want to develop a lab in mechanical engineering, you have to click on mechanical engineering, and you will get all the labs which are already developed in mechanical engineering area. So apart from these labs, if there is a lab in your institute that is used in mechanical engineering branch and you want to develop those labs, so that is called a gap area. After that, you can also go to a link that VLabs IIT or simply say VLabs Dev portal or another portal that is VLabs Dev. If is there any lab that is in your institute and that is already on VLabs Dev portal, you need not to develop those labs. We have to develop those labs which are not on VLab.co.in portal as well as on VLabs Dev portal. Okay. So these are the software details. Means we have to use open source software only. The software which don't include or which don't ask for a license. That is HTML, JavaScript, Python, Google Web Designer, or any other software that is open source, which don't require any license. Okay, so we have to use only open source software in particular labs because this is the requirement of MHRD that they don't because we have some labs in LabVIEW before, but they want that as LabVIEW is a license-based software. So ministry now wants that uh, uh, the software you are using is totally open source, which it not includes any license. Okay, so these are the facts. Means you can propose maximum 3 labs or you can work maximum 3 labs. This is for a particular nodal center like GB Pankaj or this any other institute is our nodal center. They can only apply for maximum 3 labs, or they can only propose 3 labs. Okay, so there should only 5 members in a particular team. Okay, 5 members means 3 from particular branch or 2 from the coding part from the software end. After that, deadlines to submit the labs. So when you apply for a lab, when you propose a lab, within 3 months you have to the submission of that particular lab, or simply we'll say that हम लोग 3 महीने में ये एक लैब कंप्लीट कर देते हैं। आपकी लैब्स में मैक्सिमम टू मैक्सिमम 7 एक्सपेरिमेंट्स होने चाहिए, 7 से ज़्यादा ही होने चाहिए, मिनिमम 7 चाहिए। आप लोग 3 मंथ्स में वो लैब हमें प्रपोज करेंगे और सबमिट भी करेंगे। ठीक है, हाउ मच टाइम विल टेक टू अपलोड द फाइनल लैब्स, लाइक आप लोग जब हमें वो लैब सबमिट कर देंगे, विद इन 1 मंथ दैट पर्टिकुलर लैब विल गो ऑन वी लैब पोर्टल on our vlab.co.in, that is our central portal. Okay, so these are some glimpse of boot camp. We organize a boot camp in large than in our IT Roorkee. So participants from many institutes came here and they developed some good labs. Like if you see a lab is there, electrical machine simulation lab. This lab is developed by the participants from different institutes. So I think this is all from my side, from development side. Like, if you have any query or you want to ask anything about this development activity, you can ask now, or you can note down the contact numbers. Rajiv Kumar is SRF in our lab. He is a member of development team. Jaspir Singh, my name. I'm also a member of SRF in virtual lab, and Priyanshi Agarwal. That's he in development team. If you have any query regarding this development activity or how you can develop these labs, you can ask directly. Okay, or you can email us on our email IDs, that is virtual-lab@iitr.ac.in, and this is our lab contact number. You can take a screenshot or you can like save the numbers. Okay, so if you have anybody have any query, you can ask now. Friends, अगर आप लोगों की कोई भी query है, आप लोग अभी पूछ सकते हैं. आप लोगों को चैट बॉक्स भी है, वहां पे आप लोग चैट बॉक्स में अपनी क्वेरी लिख सकते हैं, या किसी की भी कोई क्वेरी है अभी पूछ सकते हैं. मैम, सुधा मैम.
Yes, thank you, Jasmeer ji.
मैम,
And
एक बार आप भी एक बार बोल दीजिए ताकि स्टूडेंट्स आपके कहने से पूछ लेंगे शायद, अगर उनकी कोई क्वेरी है. मींस अभी ये क्या है, अभी लोगों को उन लोगों को शायद चीजें समझ में नहीं आएंगी, बिकॉज ठीक है, जब वो लोग उसमें इन्वॉल्व रहेंगे तब समझ में आएंगी. बट फिर भी अगर किसी की कोई क्वेरी है, यू कैन आस्क.
स्टूडेंट्स, इतना अच्छा प्लेटफॉर्म आपको मिल रहा है जानकारी के लिए, तो कोई भी आपकी बिल्कुल चाहे छोटी से छोटी क्वेरी हो, हेजिटेट मत करिए पूछने में,
यस,
क्योंकि हो सकता है जो आपको छोटी लग रही हो वो हमारे लिए भी यूजफुल हो. बहुत
एग्जैक्टली
बार
मैम.
हम ऐसा सोचते हैं कि इस क्वेरी से हमारी लोग हंसेंगे हम पे या सोचेंगे इतना भी नहीं मालूम, और वो बहुत सारे लोगों की क्वेरी सॉल्व हो जाती है. So
जी जी
don't
जी मैम.
hesitate, and whatever small query you have or a big query you have, without any hesitation, you can send either it to chat box or you can directly ask. So, uh, students, you are welcome to ask your queries.
Excuse me, ma'am.
Yeah.
Uh, uh, Morning, sir and ma'am.
Good
I
morning.
am I am Himanshu, and I am a final year mechanical engineering student.
Okay.
My query was, can you provide us like a time frame for the boot camp and the internship so that we could manage in like with our
See,
upcoming exams and stuff?
exactly. Himanshu, what we will do is, when you send us a proposal,
Right,
hello,
sir. Yeah,
okay,
I'm
when you
listening,
send
sir.
us a proposal, we will notify you the date of boot camp, and we will fix the date on which you don't have any exams or, okay,
Right.
okay.
So
हम
what
लोग
is
जो
the
भी बूट कैंप
exact?
ऑर्गेनाइज करते हैं यहाँ पे, हम लोग ऐसे सेमेस्टर में या ऐसे मंथ में उसको ऑर्गेनाइज किया जाता है जिसमें स्टूडेंट्स का कोई भी एग्जाम्स वगैरह नहीं है. ठीक है. So
Right, sir.
for that boot camp, you have to first propose us a lab.
Right, sir.
Okay.
And sir, that will all happen through the online portal, the development portal, right?
See, right now we don't have any other option because we are doing all the things online mode. But
Right,
if the
sir.
things will go easy, then we'll organize a boot camp in next semester so that we'll come and we'll meet face to face physically.
Right, sir.
Uh,
Thank you so much.
okay, Himanshu. Thank you so much, Himanshu. एनी अदर स्टूडेंट? सी, देखो, हिमांशु को अभी एक क्वेरी पूछनी थी, उनको डाउट था. आप लोगों को कोई भी ऐसा डाउट होगा तो आप लोग पूछ सकते हैं. आप लोग चैट बॉक्स में लिख दीजिए जिसको नहीं पूछना है, बिकॉज अगर आप लोग डाउट्स पूछेंगे तो काफी अच्छा लगेगा. ठीक है, बिकॉज कोई डाउट नहीं पूछता है तो दो ही चीज होती है, या तो आप लोगों को बिल्कुल सब समझ में आया है या फिर सब ऊपर से गए हैं.
नहीं जसवीर जी, आजकल एक और ये है कि यू आर नॉट प्रॉपरली कनेक्टेड टू द ऑनलाइन
एग्जैक्टली एग्जैक्टली मैम, थोड़ी सी प्रॉब्लम होती है, हम जानते हैं. ठीक है, बट
मोड.
अगर किसी की कोई ऐसी क्वेरी है, आप लोग डायरेक्टली हमें कॉन्टेक्ट नंबर पे कॉन्टेक्ट कर सकते हैं या हमें ईमेल भी लिख सकते हैं. ठीक है. ओके, आई थिंक दैट्स ऑल फ्रॉम आवर साइड मैम.
सक्सेना सर, तिवारी जी, मनीष.
Hi.
हाँ.
Thank you, Dr. Jyotir Singh. I have a small query.
यस 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 सर, प्लीज.
Can students join some other IIT team or NIT team in order to develop a lab?
Sir, if the lab is from your institute, means we'll think that only your member team, your institute team will. Hello.
Yeah.
Sir. Actually, what we'll do is, like you propose us a lab, you send us a team detail. So,
Right.
any other institutes also, also contributed in this particular platform in VLab Dev community or VLab development activity. So, we
Right.
will provide the contact numbers of other persons also. They will interact with other some IITOs or some other NIT students also. So,
Right.
but I think कि अगर आपके कॉलेज से जो लोग हैं, जो टीम आप डिटेल्स भेजेंगे, अगर वो लोग इसमें, बिकॉज हम उनकी हेल्प करेंगे पूरी पूरी, कोई भी चीज़ होगी हम उनको बताएंगे कि उनको कैसे करना है, स्टेप बाय स्टेप होता है, बहुत इजी प्रोसीजर है, दे कैन इजीली डू दिस।
Okay, thanks.
ओके सर।
Jasmeer ji, I don't think that there is any query from our side now. So
ओके,
you can continue, or your team,
आई
if
थिंक
some.
मैम फ्रॉम आवर साइड इट्स क्लियर एंड आई थिंक दिस इज, आई थिंक वी हैव टू एंड दिस because no other query and we from our side.
Okay, thank you, Jasmeer ji and your team, Chetan ji, everyone.
So much ma'am.
Because it was actually initially the student may feel that this may be not of that much use, but once they become used to of this, they will enjoy it and they will learn many things from this.
Exactly.
Yeah, thank you once again.
Okay, thank you so much ma'am, thanks to everyone, thank you so much.
Thank you, students. Thank you, faculty members. And I think now we should leave from this meeting.
Okay, thank you.